Welcome, everyone. Welcome to the concluding day of the Pearcey Foundation's Australia 4 discussion series. Today is our summit, and that has been some time in the making. My name's Wayne Fitzsimmons, and I'm privileged to be the chairman of the Pearcey Foundation, in case you hadn't noticed the background. The Pearcey Foundation acknowledges all the traditional custodians who belong to the lands where the Pearcey Foundation and you, our guests, meet, live and work. We acknowledge the Aboriginal and Torres Strait Islander people with us today and their elders past, present and emerging, whose stories, traditions and living cultures in this country are a valuable resource, as are those of us all who have come to make Australia their home. Together, we are Australia. Your voice is expected to be heard in this discussion, so please use the raise hand function to ask questions, make comments once the moderator signals questions from the floor have commenced. And please note that this session is being recorded. And we will now show you a brief video about why our foundation came into existence.
I think Australia has a terrific record for being inventive.
There's clearly a brilliant, innovative streak in Australians.
We've had an honourable role to play.
It may be due to the circumstances, their isolation, the need to be creative.
We had some early innovations. In 1854, we had our first telegraph line between Melbourne and Williamstown, the port.
A lot of the first forays into electronics in Australia were about telecommunication.
Outside of America and England, was the first country in the world to use Morse code.
Morse code revolutionised communication, and it wasn't long before those telegraph lines spread like spiders' webs all around Australia.
That was the Victorian internet.
The Darwin to Java undersea cable was put in place in 1871, and it was to connect to the overland telegraph line. We then had cable contact back to Europe.
The businesses that used the Morse code the most was in fact the wool industry.
And we had an extraordinary inventor called Henry Sutton.
Henry Sutton had designed the first of the rechargeable batteries.
He was very much a self-taught genius of his age.
The compound telephone, which we know today, which has one piece, came as a result of earpiece at one end, microphone at the other, all off the same magnet. That was a brilliant invention.
Alexander Graham Bell comes to visit him in Ballarat.
Bell had that telephone in two pieces, and Henry Sutton made it in one.
And you've got companies doing high-tech things.
Radio was explosive in its growth through the 20s.
It was vital that Australia have communications, particularly communications with the ships at sea.
The whole electronics industry in that period, from 1920s onwards, was dominated by the firm AWA and by its chief scientist, Sir Ernest Fisk.
So he thought he could communicate with the afterlife, with the dead, with radio. They're starting production of vacuum tubes. They're realising radio's huge.
This is called a Traeger pedal. It became familiar to people on stations to use the pedal radio to communicate with the doctor, to communicate with each other.
Radio in Australia is probably seen as a little bit more vital because it's a big continent.
In Australia during that wartime period, one of the most important developments that took place was at CSIR Radio Physics, where they developed the distance measuring equipment.
In World War II, Australia had developed portable radar systems for our soldiers to take into the field in jungle warfare, and that was fairly extraordinary in its day.
During 1946, I began to develop ideas for an electronic system for computation. Towards the end of 1947, I had more or less completed a theoretical logical design for what was to become CIRAC.
CIRAC came about because it was part of the general development across the world because there was a need for high-speed computation. CIRAC was the brainchild of Trevor Pearcey and Maston Beard.
The machine was well conceived and well engineered by the team at Radio Physics.
CIRAC has the greatest Australian content of any computer ever made.
There were only 3 other computers in the world.
It was a huge advance over the calculating machines, which was all they had.
CIRAC was the first computer to generate music.
Colonel Bogey's March was the first thing, which was a very popular tune of its day. You know, da, 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 da.
And that was the first use of a computer to generate music in the world. CIRAC, in later years, when it was in Melbourne, was the first computer to generate a 24-hour weather forecast.
It was an extraordinary machine. It did extraordinary work. It found the centre of our galaxy.
They developed games that people could play using the cathode ray screens and the flashing lights.
It was a remarkable machine created and maintained by remarkable people.
One of the more significant Australian inventions in electronics was the black box float recorder.
And of course the atomic absorption spectrometer, which was a CSIRO development.
Australia's always been in the forefront of television research.
Australia kept pace. Australia kept pace with the rest of the world in this technology.
The reason why biomedical is because you've got this huge centre of biomedical research here, which needs hardware and needs instruments and things like that.
They were experimenting.
There was the bionic ear.
I have spent the greater part of my working life focused on developing what turned out to be a bionic ear or cochlear implant for profoundly deaf people.
And the pacemaker.
In fact, in 1971, Telectronics was the first company in the world to put a hermetically sealed pacemaker on the market.
So there's certainly people doing some very clever stuff in that area.
In the very late 60s, early 70s, Dick Smith came along and started up Dick Smith Electronics.
I'm going to sell electronics and I'm going to do it in a revolutionary way.
And then straight after that, we got the very first digital chips, CD4011, 4001, and this was the beginning of the digital era.
Late 70s, mid 80s was sort of like the golden age of hobby electronics, I think.
It was magazines, it was buying kits, there was a computer club.
First projects that I built myself with some friends was the National Semiconductor kit called the SCAP.
These were times when it was really quite a mensa test to get the smallest computer to do the smallest thing.
There was an enthusiasm, almost a religious zealot of interest in these parts.
I think it was. I think that it was very exciting for people to be able to build something which used a chip. It was a concept which was new.
The first commercial computers were starting to come in, the Dick Smith Sorcerer, for example, then the Australian Micro Bee.
Unix became the thing.
Australia also built the Fairlight, which is the world's first digital sampler, and Fairlight expanded. It became a very innovative audio editing tool for post-production. Post-production being the synchronisation of sound to image. Basically, the Fairlight system is still incorporated inside the Blackmagic system these days. And Rode Microphones now, one of the world's most successful microphone manufacturers, is in Sydney.
I'm particularly proud of what I did there. The NT3, which is a little pencil microphone.
The CSIRO is government controlled and they've had some big intellectual property wins recently with the Wi-Fi patent which they won, which is absolutely incredible.
There's been a long process of innovation and discovery.
Good morning to all of you, wherever you are in Australia or overseas. Welcome to the concluding sessions of Australia 4. This is the first of two for our A4 summit today, which will conclude. The second one will start at 11:30. So this one will finish at 11:30, and the second one will start at 12:30 Australian Eastern Standard Time. Australia 4 is an initiative of the Pearcey Foundation to recognise and moving towards a net zero Australia. The transition of our electricity system to a decarbonised environment presents an enormous number of challenges, which with each of these challenges comes some significant opportunities. Today, we are applying a particular digital and data lens when looking at the intersection of the electricity distribution system with the ICT sector as we make this transition. Our preliminary communique summarising our collective sessions and thoughts has been published and is now available on our website, www.pearcey.org.au. I would encourage you all to read after today, and don't hesitate to contact any or all of us with your feedback. So how did we get here today? Bill Wood, who I hope is participating in the audience today, and I, along with Jordan Green, were made aware of the energy transition issues that arose as we moved to a renewable world with multi-directional energy flows. The three academics we encountered in 2018-19 were Pierluigi Mancarella, the Professor of Leckenge at Melbourne, Professor Tapan Saha from the Leckenge University of Queensland, and Professors Julian Epps and John Fletcher at the University of New South Wales. And they stimulated Bill, Jordan and I to, we've got to do something about this as an industry. The upshot was a recognition that ICT was fundamental to making this transition from current systems to the one that is primarily characterised by bidirectional electricity flows from multiple sources, sinks, and storage devices. Sounds like a real-time distributed network we're all familiar with in our industry. So, with a bunch of enthusiastic supporters, including the above, as well as Dr. Michael Breer from Melbourne University Energy, Neil Horrocks, along with Jennifer George, Colin Farrelly, we got started. Professor Chris Manzi, head of Leckenge at Melbourne Uni, has been particularly encouraging and supported us financially, along with Monash University, University of New South Wales, and most importantly, the Australian Computer Society. Along the way, I've met some amazing folks who have reached out to support this initiative. Many of them, or all of them, are on our panels today. One group who is not represented directly on this panel is Standards Australia, but I want to thank Mike Brownlaw for his enthusiastic support. However, they are really part of today because both Ian Opperman and Jennifer George are active participants, and perhaps many of you listening, in various SAA committees. Today is follows 7 Zoom sessions, which were an overview of the challenge, the future grid, network intelligence, grid resilience, the consumer grid, the role of telecoms, and some of the critical digital technologies that will be required to get us through this transition. And now we've come to our first session today, where we will review the key learnings from these 7 sessions. To lead us through these discussions is Dr. Ian Opperman. Ian is currently New South Wales Chief Data Scientist and Industry Professor at UTS. Ian has had a long-term involvement with big data and data standards and works closely with Standards Australia and the International Electro Commission, IEC. He recently completed a major piece of work for the New South Wales Government on AI assurance frameworks. He has had a long-term involvement with ACS and is currently the immediate past president. Over to you, Ian.
Thank you very much, Wayne. Great to be here, and thanks to everyone who's joining. Australia 4.0 is a collaborative activity, and as Wayne mentioned, there are many parties who've been involved in this because this problem is complex and difficult. As Wayne mentioned, my name is Ian Opperman. I would just like to acknowledge I'm joining you from the lands of the Gadigal people today. So, to realise a net zero Australia, the transformation of our electricity infrastructure and policy landscape and modes of operating will be profound. The role of digital technologies in meeting this transformational challenge will be critical. And Australia 4.0 is a 2-year program that started with a series of multidisciplinary discussions to collaboratively understand these challenges and to identify the opportunities for Australian ICT industry to help enable this transition. This is absolutely a team sport. This is something that no single part of our economy, of our government, of our industry or academia has full responsibility for. Over the course of the sessions that Wayne mentioned, there have been over 100 discrete businesses and regulatory challenges which were identified in those 7 sessions. And Wayne mentioned that the draft communique has been established or been released, and that was actually collated using the help of AI-targeted language models, which then are used to summarize a range of key challenges. And it's those key challenges that we'll run through with our panel presenters coming up in a moment. We have a really distinguished panel this morning, and we're going to recap some of the major issues associated with the first 2 panels, which covered the Australia 4.0 topics broadly and set the scene for the new energy market. And then we'll look at the reflection on panels 3, 4, and 5, or sessions 3, 4, and 5, which looked at the business, regulatory, and operational challenges and opportunities, of course, in that new energy market. And then we'll hear from our last two panel members representing the last sessions, where we're talking about the ICT opportunities specifically identified. Our panel today is Jordan Green, who has many, many roles, including a Pearcey role, but he's founder of Yarrawa Capital. We have, of course, Wayne Fitzsimmons, who we just heard from the Pearcey Foundation. We have Stephen Craig, who's the Smart Energy Mission Lead at CSIRO. Jennifer George, again, many, many roles, but one of them is the CEO of Strategic Commercialisation Australia. We have Tim Ryan, again, many hats, but one of them is founder of Ready Energy. David Hill, who's from Monash University, and Patricia Boyce, who's with the Centre for New Energy Technologies. And what I'd like to do is very briefly invite, first of all, Jordan Green and then Wayne Fitzsimmons to recap some of the most important elements of the sessions that they ran. Then we'll turn to Stephen, then Jennifer, then Tim, then David, then Patricia. So Jordan, without further ado, I'd like to hand to you.
Thank you, Ian. Our first session was an introductory overview of the challenges and opportunities. Professor Michael Greer from the Melbourne Energy Institute at the University of Melbourne kicked off the session by presenting a summary of a report launched just days prior to our Australia 4.0 session. That first report from the Net Zero Australia project is a collaboration among the University of Melbourne, the University of Queensland, Princeton University, and international consulting firm, the Nous Group. Michael emphasised the scale of the challenge ahead in terms of the environmental, economic, and human resources. Excuse me. He highlighted that we have a time factor that exacerbates all of these challenges. The report offered several scenarios for Australia to reach our goals. Commonalities include incorporating the carbon impost of our exports, seeking to onshore more of our resource processing, and generating the required supply of skilled workers. To make all this happen within the desired timeframes is likely to require at least $7 to $9 trillion. Michael suggested much of that could in fact be funded by our export customers through the use of long-term contracts, such as are currently used for LNG and coal exports. On the jobs front, Michael suggested that by 2050, we need to increase the energy sector technical workforce from the current 100,000 people to 800,000. These will be secure, high-paying, and interesting skilled jobs, split about 2/3 for TAFE graduates and 1/3 for university graduates. Next, we had Dr. John Ward, Research Director of Energy Systems at CSIRO. He addressed the scale of the challenge in terms of emissions. Today, Australia emits around 550 megatons of CO2 each year, and we have committed to reducing that by 43% in the next 6 years. John emphasised that almost all of that reduction has to be achieved through the energy sector. John noted that net zero demands a fundamental change in how our energy systems work. We're migrating from a small number of large-scale centralised energy generators to millions of small-scale power electronics-driven inverter-based generators distributed across the different elements of the energy grid. John proposed that this increases the complexity of the challenge by 10 orders of magnitude. Then Professor Neil Horrocks, who is Director of the Centre for Energy Data Innovation at the University of Queensland, took us to the customer-facing elements of transformation. Neil identified 4 key areas where customers will significantly impact the energy transition: electrification of everything, orchestration of distributed energy resources, cybersecurity, and the application of various versions of artificial intelligence. Noting that electrification of everything is happening to all of us, Neil highlighted the need for the ICT industry to help with managing the data, balancing information needs of different players in the market, and identifying the shifting loads on the grid in real time. As people invest in their own generation and storage capacity, they will expect to maximise the benefit of their self-generated energy in reduced costs and increased returns. All this new interactivity across the grid will demand high levels of trust in the system, the cybersecurity to share data responsibly, and to protect both assets and identities. Neil emphasised the prospect for new AI-based systems to deliver unimaginable efficiencies, which could lead to truly low-cost energy. All three of these speakers expound a future rife with opportunities for collaboration between the energy and ICT sectors to address this transition and, in the process, generate new, competitive, national capabilities, products, and services. So just a few of the key issues identified by this panel include the extraordinary increase in complexity, demands advanced and real-time ICT solutions. The shift to massively distributed generation and storage means consumers become an integral part of the network. Among other things, that will require a complete rethink on how electricity is priced, taxed, and sold. With the radical increase in ICT systems in the energy grid, there must be a consummate improvement in the cybersecurity, agility, and data sharing across the ecosystem. Australia needs new technologies to reduce carbon emissions in our exported products. Thank you, Ian. That's my brief summary.
Thanks very much, Jordan. And quite a lot to dig into there, but we'll keep going with our quick summaries, and we'll pass now to Wayne to talk about session 2.
Thanks, Ian. You may recall these three speakers on the topic of the future grid we heard in session 2. Mark Patterson was the first to speak, and Mark is the founder of and CEO of Energy Catalyst and was formerly with CSIRO Energy. Mark discussed the transformation of Australia's power systems broadly. One early observation made by Mark was that grid planning and operations in the future grid, the grid that's emerging right now, will involve an entirely new level of dynamic and whole system interdependence across all layers of the system. He commented that Australia's national electricity market, the NEM, and we use a lot of acronyms. I've got used to them over the last few months, but this whole discussion is full of acronyms. So the NEM is transitioning from a past of a few hundred generators to a future where tens of millions of energy resources participate. Ultimately, none of this can be done efficiently without a focus on making the decades-old systems architecture of the NEM future ready. One of the critical areas where he thought the ICT sector has very well developed capabilities, which are also foundational to the digitisation of the grid, is in regard to the underpinning systems architecture required if the outcome we want is a more secure, scalable, resilient, and ultimately cost-efficient and human-centred NEM. Our second contributor was John Fletcher, Professor from the Department of Electrical Engineering, New South Wales. He is also the theme lead on the New South Wales Government's Electrification and Energy Systems Network that supports the Decarbonisation Innovation Hub here in New South Wales. He stated, "It's the network that will deliver the generation to the consumers. It's the network that enables distributed energy resources and energy storage and all the other really important things that we have to do to our holistic energy system in order to deliver this decarbonisation story. There is a physical barrier," he mentioned, and that happens to be the speed of light. And when we start talking about light not being fast enough to communicate things, then we know that we are at the extremes of what we can do with control and coordination. Such barriers pose challenges to communication systems across the network and are real. He gave an example of how quickly an inverter, we're all familiar with when you have solar cells and batteries, how quickly they can be switched on and off. His parting comment was a good reminder to us all. We're not the only country trying to do this. In fact, most of the planet is attempting to decarbonise their energy system. The third speaker in session 2 was Professor Pierluigi Mancarella. He's a good friend of mine and he's the chair professor of electrical power systems at the University of Melbourne and a professor of smart energy systems at the University of Manchester in the UK. He is also program leader Energy Systems Melbourne Energy Institute, who was referred to as Michael Breer as the head of that. And as Jordan mentioned, they recently released a major report entitled Net Zero Australia. I would encourage you to take a view. It's easily accessible on the web. And it's an excellent view into the macro challenges we face in transitioning to a renewables world. Pierluigi pointed out that with the advent of distributed resources, such as rooftop PV, power can now flow in the opposite direction leading to bi-directional power flows. However, this presents challenges as the grid was not designed for this, leading to issues like congestion, overloading transformers, and voltage variation issues. He emphasised that distributed resources are not just about generation, but also include demand response, flexible consumption, and different forms of storage. Pierluigi saw infinite opportunities for ICT in this new era of transformation, from building ICT technology for buildings and houses to interacting with different levels of markets to maintaining the safe operation of the grid. He concluded all of this requires infrastructure, intelligence, speed, and communications that we don't have at the moment. It all needs to be designed and built, and the opportunities are just infinite. And by the way, just as a footnote, the ACT chapter of the Pearcey Foundation, when we were presenting the ACT Entrepreneur of the Year Awards in 2022, the Chief Minister, Andrew Barr, I announced that we were having this A4 initiative, and he challenged the ACT chapter to give some thought in 2023 to initiatives that could accelerate Canberra's progress towards a net zero carbon economy, leading Australia in this important quest. Suffice to say, their report was submitted, and I was there a couple of weeks back in Canberra, and we handed it to the Minister. This report focused on EV charging in high rises, given the unique situation in Canberra, which is quite different from most of Australia. 50% of the population lives in apartments, and it has, unsurprisingly, the highest per capita penetration of these EVs in Australia. So the report focused on how do you keep them charged. And in finishing, let me say the main issue I've learned through these 7 sessions, and I think it will come out in both of today's sessions, is that the need to focus on consumer agency. This has dominated, come to the fore so much in the whole underpinnings of these 7 sessions. Look, there's a lot of challenges and opportunities, and they're all listed in our communique, which we've published on the website. But just to highlight 2, the business and regulatory changes are quite challenging. For instance, modelling power systems with potentially millions of distributed resources presents huge mathematical and physical complexity. I'm sure we're up to it, but it's one of so many challenges that we must address. And in terms of opportunities, managing complex power systems, given the dynamics around the emerging new systems, ICT can contribute to the architectural configuration of the future systems, which must be secure, scalable, resilient, flexible, and ultimately cost-efficient and customer-centric. The consumer agency is front and centre. So with that, back to you, Ian.
Thanks very much, Wayne. And we're doing quite well with time, which I'm very happy about. So thank you, Wayne and Jordan. Our next set of quick recaps will cover the regulatory and operational challenges and opportunities in the space. So we're going to pass to Steve and Craig.
Thanks very much, Ian, and good morning, everybody. So in the third session, we delved into network intelligence and explored what this means in the context of the future power system. Bill Wood, who co-chairs the Trusted Technology and Data Program of the IoT Alliance Australia, opened the discussion by emphasising the key role of data communications and data science in managing the increasing complexity of electricity networks. Bill highlighted in particular the importance of collaboration and trust among diverse stakeholders to build the digital fabric that's needed to succeed with power system transformation. He also pointed out the necessity of good data governance and strong security measures. Bill suggested that the ICT industry could contribute significantly to the transformation, noting that ICT has already solved a number of the challenges that intelligent energy networks are going to face going forward. So in conclusion, Bill called for a meeting of minds between ICT and power systems engineers to address the challenges and barriers achieving a net zero energy future. Next up, we heard from David Lucido, who's the founder and CEO of Sentient Hubs. And David spoke about the need to understand the interdependencies between different sectors, such as energy, water, and climate, and the challenges in achieving an integrated, holistic view of these systems with lots of proprietary interests, models, and data formats. David stressed the need for strategic decision support to help leaders and policymakers understand the bigger picture around stability, resilience, and sustainability, and the importance of modelling for consequence and not just what and when. David emphasised the importance of stress testing, resilience, and stability in complex environments in order to understand the risks and resilience of our critical infrastructure, such as energy, more holistically. Finally, Dr. John McKibben, who leads CSIRO's Energy Networks research portfolio, discussed the challenges and opportunities in the energy sector, particularly in relation to network intelligence. John broke down the challenges into three main areas: the transmission system, the distribution network, and the customer level. In the first of these, John highlighted the transition from large fossil fuel-based generators to variable renewable energy with so-called inverter-based resources such as wind, solar, and large-scale batteries as a significant challenge in the power system. He outlined system strength, inertia, and resource utilization challenges and explained the three dimensions of network intelligence. The first is visibility, knowing what's happening in the system. The second is predictability, knowing what's going to happen in the system. And then finally, control. In the distribution network area, the key challenge is the introduction of distributed energy resources such as solar PV and batteries. John pointed out that the distribution networks were not designed for this, leading to conservative connection limits or static export limits on rooftop solar and potentially power quality and reliability issues. He emphasised the need for enhanced visibility, predictability, and control in this area as well. Finally, at the customer level, John discussed the electrification of heating, cooling, transport, and industrial processes, and mentioned that if unmanaged, this could lead to a significant increase in generation and network load, with the potential to raise energy prices. He highlighted the importance of customer transparency and fair reward for contributions to the broader system, along with the opportunity for demand flexibility solutions in helping future power system efficiency, cost, and performance. Some additional issues identified by the Session 3 panel included the need to find the right balance between control engineering and market-led approaches in future networks, the need to ensure network intelligence solutions maintain operational parameters such as power system voltage and frequency within safe limits, the need to address potential cybersecurity risks associated with distributed energy resources, and the need to overcome challenges and current limitations related to data sharing and access. Finally, the panel outlined a few ongoing initiatives that have network intelligence as one focus, and two in particular that were mentioned include the Global Power System Transformation Initiative, or GPST, and the Distributed Energy Integration Program. And of course, there are several others. Thanks, Ian, and back to you.
Thanks very much, Stephen. We'll pass to Jennifer now.
Yes, thanks for joining us today, and it's great to have everyone here. My session 4 was very much about the transformation that was being made and how it would meet the needs of climate change. It was in fact about risk reduction, readiness and response and recovery, and how all of the changing climate is going to affect the actual systems that we are building into the environment, which is a paradox, right? We're building in complexity into a very complex changing environment, which is a challenge, right? So our discussion focused on 3 speakers. One speaker talked about the climate change, the risk in climate. The other speaker spoke about the operational challenges, and finally the third speaker spoke about the cybersecurity risk. So our first speaker was Jill Caney, MBE, and she's a highly acclaimed meteorologist and founder and CEO of Earn Energy. Jill presented an in-depth analysis of the impact of climate change on the electricity grid and the importance of considering resilience as we deal with the changes, right? We are not building a system in a static environment, was a key takeaway that she was talking about. And we need to be agile and responsive and reflective. Some of the key areas that she mentioned was the fact that we have, in fact, increased our air temperature by 1.5 degrees since 1910, which is when records began. So it's very hard for us to deny that the changes in the climate are not going to happen when we have already met that standard. Because of that, rainfall will be decreased across Australia by 15% in the southwest of Australia and 10% in the southeast of Australia. That's not to say it will completely be changed, because the actual impacts that we have from large-scale events, short-term events, will be more substantial. And so we'll have longer duration, more flooding events, even though we have less rain generally. We will have an increase of fire days and extreme heat days. And now we will have some of the, the heat will be one of the biggest killers here. There'll be a decrease in tropical cyclones, but the ones we have will be substantially worse. As I say, the duration as they stay on continent will have extremely damaging effects. So we need to be aware of that. We need to build the energy system to enable that. So in conclusion, Dr. Caney said that it's about households, communities, local government authorities, and state governments and federal governments all working together. It's not about just, one person owning the piece of the puzzle. We all have to work together. She also highlighted the fact that $1 spent on risk reduction will be worth up to $10 spent on remediation and repair afterwards. So very good financial basis for the idea of we should build in and understand predictive measures into the system. Our second speaker was Alex Bates, and he is the principal of the electronic engineering consulting company called BES, B-E-S, Australia Proprietary Limited, and he is an honorary professor at the University of Wollongong. Alex talked about the energy distribution networks, and he talked about the quite substantial changes that everything will be facing as we bring in the innovation, as has been previously said, of connecting millions of now producers into a system and ensuring that we have a system that can take the flexibility of that energy delivery. He emphasized the importance of risk reduction and readiness and the increasing demand of our electric transportation system. So it's not just about trying to meet our current demand as we electrify everything and we bring our vehicles from fossil fuel driven vehicles to electric vehicles, we'll have substantial growth in the electricity demand. So he spoke very highly. I was pleased to hear about the need for consistent standards and the management of these millions of customers and components, and using dynamic operating envelopes to enable that in part. He talked about the need to address safety issues and that will arise with each household and each commercial entity becoming a generator instead of just a recipient of power. And the number of components involved, he described as millions, as have all the previous speakers, were also created their own challenges. Overall, he covered regulatory issues, technology transformation, and technical issues, and they were all talked about within the context of better management and advanced management for distribution. Our final speaker was Dr. Surya Nupal. He is a senior research scientist at CIRO's Data 61 and mission lead for Critical Infrastructure Protection Resilience Mission. He currently leads the Cybersecurity and Quantum Systems Research Group, and he has 60 staff and 50 PhD students. So yeah, like some of the previous speakers also talked about cybersecurity, but this was a little bit of a more in-depth analysis where he talked about how each of the pieces that we add will potentially add a form of cybersecurity risk, and how we need to collect and bring all of those technologies together in a meaningful way so that they're all protected all along the pathway. He stated that a few producers and 1 million consumers is now moving to the millions of producers and millions of consumers. So what he called was the prosumer was now evolving. So it was not just a consumer, it was a prosumer. So the ability for customers to be both using and creating power. He also discussed the challenges of ensuring confidentiality, integrity, and the availability for continuous operation of the energy grid, and gave several case studies of situations where the power had been interrupted because of hacking or cybersecurity events. And these are worth looking at in the session. He pointed out the interdependencies that we will now be having, not because we are just energy, but everything will be connected. So it will also be health, transportation, telecommunications. Everything will start to be working together. And so cybersecurity must be a system that operates across that multiple levels in the supply chains. I had shared perspective on digital twins about as an operating system and looking at systems and how they might operate. All of the speakers talked about how AI could work potentially, but we needed a human in the loop in order to make sure it was appropriate. And collectively all shared the idea that knowledge, data visibility, and awareness were key to the potential success of that project. So all in all, a significant contribution to the conversation, and one that added a lot of value that I was very honoured to be a part of. Thank you, Ian.
Thanks, Jennifer. And last in this group, we'll go to Tim.
Thanks, Ian. I was quite lucky in that we followed on from a lot of this work that had been done by the previous speakers, and we took the position that the consumer is at the centre of this system and not before. So one of the parts of the summary that said we're here to talk about the consumer grid and how the grid has changed and where we're expecting to end up as consumers, and actually wrest control of the grid from potentially retailers and generators. We had a great lineup of speakers. We had Simon English, who's been with a number of the networks and is currently in the Victoria networks. Lachlan Blackhall from the ANU, Professor Lachlan Blackhall, who is from the Grid Storage and Grid Integration Project, which has very much consumer focus to it. And Lynn Gallagher, who is now a director of the AER, Australian Energy Regulator, but was prior to that the CEO of Energy Consumers Australia. Lachlan and Lynn will be joining Mike Bradley from the AEMC to go through some of these regulatory and consumer issues and things we're talking about in our seminar this afternoon at 12:30. So just to sort of touch on where we went with this, Simon gave some really interesting perspectives of just where the grid has changed and its reaction with the network. He said he discussed the challenges and opportunities associated with the grid from the network business perspective, but then the concept of the intelligent home will be the key enabler for the consumer. We expect the true major integration players such as Apple, Google, Amazon, Samsung, to be the home integration piece for behind the meter resources that will occur quite natively. I think that last word's one of the key parts that we're doing here, is that the consumer is just doing things and things will change in ways we haven't. And if we think of 10, 15 years ago where we didn't have digital devices in our hands, digital devices are going to be everywhere in our house and control things. Simon touched on the federal government's investment in community batteries, and I highlight the word community batteries as being for a purpose rather than neighbourhood batteries being a location. Sorry, that was my adding to that. But Simon predicts they'll be ubiquitous overall. And the reason why they will be ubiquitous is that they are buffers. They are buffers simply between what the consumer can and can't do at a particular point in time and at a highly effective cost level compared to a small residential battery, and the coming utility that's going to be with EV batteries. And Simon went on to identify that EVs were the ultimate disruptor, with manufacturers planning to only supply EVs after 2030, 2035, and emphasise the potential for EVs to change the distribution system. They offer an opportunity to move energy around our system that we've never been able to do before, and encourage your audience to view EVs not just as cars, but as data platforms and power on wheels. Simon's really crucial point there was that while we've got network monopolies at the moment and poles and wires, we're all connected to it, an EV means we can literally take the car somewhere, charge it and bring it back, vice versa, and do any of these things we need. So while we will continue to have network monopolies, there's this parallel universe running alongside it. Lachlan then jumped into delving in some of the critical work that his group has been doing to involve social science in the whole discussion we're having around energy. So a lot of the previous discussions, and it's really important, has been around the technology, how you do things, but also we needed to understand the impact of social science in it. And we need to make sure that the consumers are brought along with those things. He discussed the ongoing transition, moving away from centralised fossil fuels to distributed systems, where the generation and storage is embedded in the demand side. He described this model as being a barbell, with 50% of the generation and storage assets being large-scale wind and solar, and the other 50% being residential community, solar, batteries, electric vehicles, community batteries, etc. The system has to be user-friendly. He said the customers in the energy sector simply do not care about how we make it work. They want it to work. They want it to be cost-effective. They want it to support the transition. So we have to think about how consumers, we're talking about automation and services there that drive it, but the consumer is really ultimately focused about cost saving. And I think this is one of the biggest challenges in the transformation, and it is a transformation, not a transition, is the consumer is focused on saving, where a lot of the business opportunities that people look at for, I'm going to manage consumers' resources, or I'm going to have a VPP, or I'm going to have these other services, are largely focused on how someone else can make money and potentially share some of that consumer, but that adds cost to all the consumers. So we need to think about our community and our applications to it. Lynn Gallagher then got into discussing the power system and the importance of consumers in the transformation, stating that consumers have not adequately been informed about the changes and what they entail. The mind shift we haven't made is traditionally thought about as what was behind the meter, and we've called it behind the meter, stays behind the meter. We don't care about much what happens. You just tell us what we need and we'll give it to you. We're flipping that. But consumers don't get the memo. We've actually flipped it that consumers have a real role with their demand system. Lynn made a very valid point that, and this is something that was picked up on work done by Gavin Dufty earlier for the ENA conference last year, that consumers' expenditure on devices, assets that will talk to others and communicate with home energy management systems, etc. It's extensive. We're talking about in excess of $50,000 per household, and that's before we start moving into improving houses and the build structure, etc. So we need to think about that. Lynn brought us into a discussion around work's been done in the UK with the Energy Systems Catalyst to have a living lab. We've got to get communication out there, talking with consumers to do it, deliver it. Now, where we have challenges now is largely that the transformation of the system is such that we have these things called FRUMPs, financially responsible market participants, and they're the ones that did all the communication with the client. They billed them, they talked to them and said, here's your bill, and maybe here's how it's changing, whatever. We're now talking about how people can do demand response, how they have to integrate with their network, how they could use their network resources better. And that fundamentally changes it, and it presents real problems for the structure of our rules, the NER, and the regulation of it through the AER, as we struggle with that consumers are participants rather than just the meal on the table that has to be protected as part of the rules. We cover across quite a lot of areas of things that we want to protect. One of the classic things that we really need is standardised real-time collection of data, including smart devices to facilitate better energy management consumers. We need our automation systems that will deliver things to the homes. These technologies are here. As I talked about before already, Lynn's proposed a living lab initiative, and we need to focus on about how the consumer becomes able to have a voice, have their agency used, and be very much participants in delivering savings, not just for themselves, but for the rest of the community. And that about covers off what I've got so far.
Thanks very much, Tim. Tim said two of my favourite words in the English language, data and standards. Thank you very much. Our last recap will be from David and from Patricia, who will talk about some of the ICT opportunities.
David.
Thank you, Ian. I'm going to take my speakers out of order because the speakers in the session that I chaired dealt with the future in the present as well as possible futures. And it's probably worth us talking about the future in the present first. Nilushka Hereth works with AEMO, but was appearing at the Pearcey, in the Pearcey seminar in her own right, was talking about, among other things, some of the challenges that have already been experienced by AEMO in this transition. So there's a lot of discussion, for example, about the participation of consumers, how they might aggregate in order to participate in the market, the basis of that. AEMO's already been involved in trials, significant trials over meaningful periods of time in both the NEM and in Western Australia about how you make that happen. And there are reports on their website that go into significant detail about what worked and what didn't and what the challenges are. In the context of what we're discussing here, some of those challenges include the reliance on the communications network, which doesn't necessarily provide the level of reliability or the speed of response that is necessary to maximise consumer participation across the markets which AEMO currently envisages consumers will participate in. She then talked about, for example, SCADA. Now, SCADA's been around forever. It's a requirement to participate in the market, but it's also mission critical. And in her material, which is available through the website, through the webinar, which is up on the website, you can hear her discussing the implications that outages, material outages in SCADA systems have had for AEMO's ability to operate the market for meaningful periods of time, not 10 minutes, but days. And so our existing systems are already presenting us with issues about how the reliance that we have on ICT technologies and how that works. She talked about cybersecurity as well. Now, cybersecurity has been a big part of what people have talked about as a threat of the future. She reminded us, and in fact, I hadn't been aware of this, that CS Energy had a ransomware episode. Now, it didn't take the generators offline, it took their front office facilities offline, but it is a clear marker of the future, the things that we're all talking about as threats and opportunities. They're here and they're now, and responses are happening to them operationally at AEMO already, and they're being, thought about in other quarters. That's not to say that other people don't have contributions to make here, but we need to understand the road that we're talking about is a road we are already on. The first speaker, Ina Kulwecki, who's with Worley, talked about the road that we envisage being on, and specifically in the context of the hydrogen superpower scenario from the ISP. So the hydrogen superpower scenario, if it eventuates the way it's envisaged in the ISP, turns the NEM into the tail on a much larger dog, because the hydrogen superpower hubs of activity turn out to be in poorly connected remote parts of Australia where there's frankly not much NEM load or NEM presence right now. Now, the ISP envisages these enormous energy producing and consuming hubs dwarfing the NEM. The ISP, perhaps understandably, doesn't address a future where they are entirely separate from the NEM, something which I personally think is the more likely of the scenarios. But nevertheless, the relationship between production and consumption for domestic industry and domestic use and for export industry and export use is something that we need to think quite hard about. Now, there are enormous opportunities for the ICT sector in the growth of these export industries. And in her discussion, she went into a few of them. There are also enormous numbers on the table for investment. So it's not a scenario that we should dismiss, but the size of it and the relationship that it has to our existing systems is something that we should all acknowledge. And then Jennifer George, in her conversation, threw that all up in the air again and said, so we have a future which might look like the LNG sector, Northern Australia connected in minor ways, if at all, to the rest of the national electricity market, for example. Or we could have a completely different planning scenario which envisaged communities, regenerative agriculture, a rich and coordinated life as part of the planning of these export sectors. And in doing that, she brought into the discussion the threads of previous discussions, which have talked about the relationships between the energy sector, the water sector, the telecommunications sector, all of which the increasing relationships between which have increased the vulnerability of all three systems, as we experience not infrequently, unfortunately, when we have a disaster of some kind. But hers was an optimistic, possibilities-focused view of what we might do, as opposed to worrying about the things which we're not currently getting right. It was a very interesting session. Thank you.
Thank you, Patricia. And David, get the last recap for yourself.
Lucky last. Okay, well, good morning, everyone. It's a pleasure to be here. My session was called Critical Digital Technologies, and the instructions I had were, well, first of all, I had the benefit of all the sessions that went before, and the instructions I got were something along the lines of, like, the previous sessions have exposed lots of challenges, so maybe this one should focus a bit more on what technologies can help solve them. And I seem to recall that I didn't need to emphasize AI because that had been talked about quite a bit. So I injected some thoughts at the beginning. I just point out I'm at Monash University recently, but I've spent most of my career, and I'm an emeritus professor at Sydney Uni, leading research in engineering around the current grid. So that informs some thoughts. I really emphasized engineering and technology because the current grid, following on from the previous discussion, has been judged to be the most complex thing that people have built, humans have built. It's also been judged not universally, but as being the premier achievement of engineering in history. And electrification is now being expanded to solve climate change. So we've all heard the story that we're building the aeroplane while we fly it, but I heard Merrin York talk at a conference in Melbourne the other day in which she embellished that by saying, think of a 747, which is no longer flying, I believe, where they had 4 engines, and on one wing, we're replacing that by a whole lot of new engines, namely big solar farms and big wind. And on the other wing, we're having millions of distributed little engines. Now, the engines on the first wing are pretty much under control, but the engines on the other wing are all under the ownership of mums and dads. So how do we keep the aeroplane flying in the direction we want while it's doubling in size? I think that's a pretty good image. And as someone else at the same conference said, well, we're starting to realize how big this elephant is that we're trying to take on here. So it's a huge engineering task and technology task, absolutely unprecedented. So with that introduction, I look back over the sessions, and we saw two themes that came out, many themes, but 2 big ones that came out of the previous sessions were data. Ian, you'll like to hear that word. It's not about big data. It's about having the right data in the right place, in the right amount. Too much is a problem, and at the right time in order to implement the right actions. And the second one was coordination, which I'll embellish on a little bit later if I get time. This huge engineering task, I heard a guy say once recently in the industry, when are we going to realize this is like a wartime effort? This is like a massive nation-building engineering task, and it's got to be coordinated, and it's not being coordinated. Come back to the 2 wings analogy. Okay, well, with that background, we had 3 stellar speakers, 2 of them in the room today. The first one is Stephen Craig, who you just heard from, who is the mission lead, is it? It's Smart Energy Mission Lead from the CSIRO. And he brought, we asked each speaker to bring just 2 major technologies that could be useful for the energy transition. And the first one he brought was music to my ears. It's systems engineering, model-based systems engineering. You do big projects with engineering. And he gave a very jarring example of a major engineering task in Spain where they built tunnels and built trains that didn't fit the tunnels. It would be staggering to think of the cost of that mistake of not using systems engineering. And he went on from there to talk about dynamic resource management. There's so many tools out there to solve engineering problems involving, you know, people, money, equipment. And are we bringing that to the energy transition? Well, not in a coordinated way, I would suggest. And that was Stephen's contribution. The next contribution was from my colleague, Dr. Sarah Goodwin at Monash. She's in the Faculty of Information Technology there, but she is also a director in the Grid Innovation Hub at Monash University. And she picked up on this theme of the right data in the right place at the right time, and used a couple of examples where that can be very useful to the energy transition. The first one being her work in energy control rooms. As was just commented on, these are not new problems. Control rooms have been a discussion, you know, how to make people and computers work together for as long as I've been thinking of these subjects, but it's just getting more complicated. So we have real questions now about how much people, when things are so much faster, so much more complex, we have real questions now about how much can people do and how much we need to rely on technology. Self-driving cars being an example. Are they safer? We're being challenged all over the place here, and I think we need an open mind that there are serious advantages in using good technology. She also referred to geographical data, which is a project I've got at Monash now, working with climate scientists, engineers and climate scientists. Well, not just me, many people at Monash are now into this subject. The energy system is total, and it was touched on in a few of the talks through the series, that the energy system now is totally embedded in weather. So all from one end to the other, and with extreme events part of the story. So we need better methods of predicting things, forecasting, and analyzing after the event when things go wrong. So that's a big story about data, but the right kind and the right amount. You know, I'm not a big fan of the idea of big data, as if big is better. But anyway, that's another story. Finally, we had Ian as our speaker, and he referred to the fact that while yes, we're partly inspired here by similarities of a future energy system with the telecommunication systems, there are differences. You know, one deals with pieces of information, the other one deals with pieces of dangerous stuff called electricity. And also he referred to the fact that we can't just barge into using models from other areas as if they're going to immediately apply in another area. And we can see that now. Our area of energy is so politicized, and it's not over. We had the climate wars. We've now got all sorts of political intrusion into our subject still going on. So that makes coordination harder. And we asked Ian what governments can do, and there was discussion around that, and you can see some of the points that came out of that discussion on our draft communique. I would just like to comment that as a kind of postscript that several of us attended the All Energy conference last week, and well, I just finished a consulting job where all kinds of concerns came up from industry about the excessive complexity and delays on getting things connected, that there's no coordination, they can't find workforce. So there was a bit of doom and gloom there. But at the All Energy Conference, there was a lot of discussion about how, while digitization only had one session, but there was a lot of discussion around things that are where I see digitization can help. Well, there was a kind of overwhelming idea I saw from a few places about we need stronger engineering leadership, but that's probably not such a point here. We need changed regulation and policy for renewable energy zones and distributed energy resources, both those two wings on the aeroplane. But a big one was workforce capacity, how to educate, as the chair of the Clean Energy Efficiency said, we have a lot of technology. Maybe we need some more, but we have a lot of technology already. But who's going to do it? Where are the people to do it? So then you see new software like TerraDo that Cannon Brooks is supporting, where you can match people and jobs and training and so on. So there, IT can play a big role. Whether it can help with social license, educating people, bringing people along. But anyway, there was one session on digitization and it was quite upbeat about energy being the next big thing for the ICT area. Let's hope. Anyway, I think that's my summary for now. Look forward to questions.
Thanks, David. Now, we've had an opportunity to listen to all of those summaries, and there's a lot. There's really a lot. I mean, the complexity of these networks is in itself a major challenge. Dealing with the speed of light. It's not the only network where the speed of light's a challenge, but it's something which is a fundamental. And of course, talking about climate resilience and designing for climate resilience are all speak to just how significant this problem is. At some stage during this feedback, I thought, oh my goodness, this is so hard. Perhaps we shouldn't try. Perhaps we should give up and not do anything about it. But we are here because we care. We're here because we think we should do something about it. And we're here because each and every one of us has a role to play in that transition towards net zero. Wayne and Jordan, I'm going to come back to you just because you started this conversation talking about some of the big challenges. What are, of all the distilled summaries of all the different areas of skills and technology and privacy and resilience, what are the biggest issues that really will get us motivated to make progress in this direction? Wayne, I'll start with you and then pass to Jordan. What are the biggest standout issues that we need to address?
Well, yeah, thanks very much. It's an easy,
it's an easy one.
Yeah. To my mind, it's a here and now issue that the price of electricity keeps going up, and it's going up substantially, and our political leaders keep telling us it's going to go down and so on. So seems to me there's a gross lack of appreciation of the change, the transformational change in the distribution system, let alone, what AEMO's challenges are, but the AEMC who set the rules and the AER who enforce this recognise that there's something radical that's got to shift. And I'm not sure what the key is, but our efforts here with Australia 4 is an attempt to sort of highlight the challenges. We haven't come up with solutions, but if we're going to resolve this transformational process, we have to understand what the problem is that we're trying to solve. And I guess I'm sorry to say this is more complex than I ever imagined, and we're going to have to take incremental, how do you build an elephant? We're going to have to do incremental bits. And I think that's what I've learned, is that that's more important than ever. And what we do, for instance, in our group in 2024, even though we've narrowed it down, not interested in nuclear versus pumped hydro versus solar versus wind, it's how do you manage the stuff where it's transmitting and receiving and storing all at the same time. We have to break it down into engineering areas that we can actually address in a coordinated fashion. That's what I'm even more, and of course, overriding that is the consumer agency in this whole process. And if we ignore the consumer agency, it'll be at our peril.
Thanks, Wayne. Same question to you, Jordan.
Yeah, well, I think, continuing on from where Wayne left off, there's already most of the technology we might need, both in terms of physical infrastructure and in terms of software, to do the things that we might need to do. But the social license to operate and actually understanding the economic model, one of the biggest challenges here is that we're trying to transition a fixed industry model from the old physical model of the industry to an entirely new dynamic, an industry that does not have the same shape, does not operate in the same way. And we have to change the revenue structures, the tax structures, the entitlements, the margins, and who gets to collect the economic rents along the supply chain. All of that has to change. And that means it's a massive challenge to the incumbents who would much rather business as usual. And it's a massive opportunity to new entrants. But bringing all of that together and figuring out what the right model is, and that's part of the discussion that's been going on in the chat today already about rooftop solar. I think that's really one of the biggest challenges here is the socio-economic concept of energy. Is it a right? Is it a utility? Is it a fundamental safety net? Sure, one conversation last night brought up the idea that, well, we could treat it like Medicare and make everybody pay an energy levy so that it can be provided to everybody. Not suggesting that's the right thing or even a good thing, but my point is there's this whole big picture need to reconsider exactly what the operational and economic model of energy is. For us, and frankly, if we get it right, it's another one of those things we could share with the rest of the world.
I'll just finish off on one note that our friend from ANU during Tim's session, Lachlan, put up an image of a switch. And you can switch it on and you can switch it off. This simplicity of electricity as a service for doing all sorts of functions in the household and industry, we have to bring it back to that. So we've discussed this before, the model of how the use of the telephone transitioned over many years to what it is today. You just pay a fee and you get all these different services. Can we conceive that that's a potential model to resolving this and a way of breaking it into smaller, manageable pieces?
Thanks, Mike. Tim, I'm going to throw to you. I'm going to ask you about the business of energy transition and what are the biggest barriers to businesses or incumbents or people who want the status quo to stay? What do we do from a business perspective?
It's an extraordinary challenge, really. But unusually, like in Texas, when ERCOT, which is very much the same sort of market as us, went through its deregulation phase, gentailers disappeared. In the UK, you can't be a generator and a retailer, you're one or the other. In Australia, greater than 80% of the market is with 3 gentailers, and then you throw in another couple with Alinta, which is outside the NEM, mainly to Western Australia, and Snowy Hydro. We've got this huge concentration of people who are both invested in the generation and the retail of it. And they're the ones that have the communication pathways to the consumer. And that presents really big problems if we're trying to communicate to the consumer how their demand, their flexible demand, could change what they pay for it. At the moment, the idea is it's always been, you trust us. We've got the regulator making sure we do the right thing. We'll give you energy and we'll charge you a bill. That's clearly not possible with the variable renewable energy because the supply is now variable. We can't guarantee control on the supply side. So therefore we bring in the demand side to save consumers money. Now, the consumers want to save money, but anyone in the energy business goes, I want to manage your resource. I want to manage your load curve. I want to buffer it, change it, do whatever, so I can make money off everybody else in the pool. And that's a fundamental shift if we're really going to get, some sort of cooperative type approach to how our energy is used. And, I look at a lot of these business solutions when people come along. Consumers, when you talk to them, will do an awful lot to save a few bob, but they necessarily won't go out of their way to make a few bob. And we need to sort of work on how that works. And, when you can go into Bunnings and buy smart electrical equipment that can turn on and off at your voice command, or have a trigger from some other piece of equipment, that's fundamentally changing the way the world works.
Thanks, Tim and Jennifer. I'm coming to you next. Similar question, perhaps adding a regulatory component to it. What helps drive the change from a business perspective, and is there a regulatory component to that?
Yes, there is definitely a regulatory component, and they have to be overcome. There's a lot of rules, not only in the generation level or the transmission level, and then in the consumer level. All of those things will affect the uptake of renewable energy. And so, like when we have our EVs, there's regulatory challenges around how we can set them up. It's consistently across the board, there's problems that need to be overcome. So that's why people have to work together. It's absolutely critical. The business challenge is that the model is typically not that we work together. We typically in business have a competitive edge, and we typically say, well, this is what we have to do for our shareholders, and this is what we have to do for our value proposition. But now we've moved to a shared value proposition. The climate change and addressing climate change is very much a shared goal, not a corporate goal. It is that the corporate goal is part of it, but it must be shared by everyone. So yes, the regulatory landscape has to change. The standards have to be developed to be able to understand where we need specifics. So if standards are fundamental to to scale, right? I commercialize technology, so we are all looking at building new technologies, looking at new solutions for the market. So we have to put standards in place and understand the regulations, and get the regulators to say with some urgency, if this is going to be brought forward, then we need to look at it. It doesn't mean that it has to be expressly changed, but we have to provide a way that the regulatory rules align with the goals, this big shared goal that we have.
Thanks, Jennifer. Stephen, I'm going to come to you now. Assuming everyone's willing to do it, assuming everyone's got the financial motivation to do it, what are the operational challenges, the biggest operational challenges? Jennifer touched on standards just there, and I genuinely believe that standards are part of the answer. But from your perspective, what are the biggest operational challenges?
There are a few. I mean, I think the biggest one is where you need to start is this question of system architecture. I don't think we've had a well-described system architecture to date, and now we're looking to fundamentally transform a system to a new operational paradigm. And having that blueprint of what we're working with is going to be really important. When I hear comments like, hey, the speed of light is not quite fast enough, it makes me think that maybe we have an architectural problem in how we've designed our system. So on the macro level, we've talked about this, the fact that 50% of the generation capacity may be coming from the traditional distribution networks, and they fundamentally have not been built for that in terms of having the visibility and the predictability and the control. So that we need to do. But in order to change, we need to get that architectural blueprint in place, what we've got now, the target system and the transitional states, and that will guide, I think, what needs to come into place to support future operations as well.
Right. Now, I'm going to go to our last two. I'm going to go to David and then Patricia. David, speed of light, ICT, information data does travel at the speed of light. And everyone's had one of those situations where they'd like speed of light to be slightly faster, but it just isn't. What are really the big ICT opportunities for transition to net zero to try and address some of these issues?
As an engineer, we had an interesting debate come up a couple of times in the all the sessions about markets versus engineering and technology. I remind people that the history of the current grid was like 100 years of solving engineering problems. Markets came into the picture in the 1990s to give a framework of competition. They worked for operations, but pretty much failed for planning. And now we have or market-based thinking, that's personal opinion, didn't do too well for planning. And now we need a whole new planned and operated system. So I just go back to technology and engineering in a general sense that we have to see this problem as other speakers have hinted at, particularly Stephen just now, as a big coordinated machine build. We're building a big machine, and that involves control, like that 747 airplane. So systems and control and associated areas of optimization, AI, database methods for the construction of the system, but then all the associated activities like getting the workforce trained, getting like at this all energy conference, there was a comment on how slow training is. It takes 4 years to build an engineer or 4 years to get the certificate, and then you need more. So how can we speed that process up with something like micro credentials, online learning in targeted areas, or someone signs up to a certain job and they get the training they need then? I don't know. I think it's too big to say what opportunities are here. They're immense. We have to do everything differently, but I do think engineering and technology is the base.
I've got a request from Tim to jump into the conversation, but Patricia, I'd like to throw it to you just to get your view on this. Given that you're from the Centre for New Energy Technologies, what are the big ICT or technological things that we need to address?
What the Centre's doing right now, and this I think is an expression of our view about the priorities, is that we are looking in detail at the distribution network and what delivering the ISP Central 2030 scenario means specifically in terms of the distribution network. Now, there are other projects that have looked at bits of this, and indeed the Centre itself has funded work that's looked at EV charging penetration into distribution networks. But right now, David was just talking about a failure of planning. From a distributed future, the major failing of planning has been that the distribution networks have always been conceived of as a black box. And so when it is now critical for us to understand, if nothing else, whether AEMO's views of the flows into and out of those networks are well-based, or what it would require for those flows to be achieved, we actually have very scattered and not necessarily well-based data. And so what the Centre's doing right now, or has been doing, for a project I think that's been in progress for going on for a year, is actually doing that in Victoria and looking at what that means as a basis for saying, well, what would that mean for distribution network capacity, for distribution network capability, for distribution network investment? And what does it mean for the timing and complexity of the visions that we have about, oh, well, we'll have millions of customers interacting together. If millions of customers interacting together requires a massive new and expensive investment in distribution capability, then going back again to the questions that were raised earlier, we have to have a good hard think about exactly what that capability is there for and how much we can afford.
Thanks, Patricia. Tim, you wanted to raise a point.
Oh no, that was really worth waiting for. I'm so on the same page as Patricia on some of that, or most of it actually. The interesting thing is in Victoria, they've had smart meters available for a long time, and the data's there. And in fact, there was a very good paper presented by one of Patricia's staff in one of the EV sessions last week at All Energy, where they'd collected and collated data on detecting EV charging around when people did it, and did a very great piece of work, because it was also looked at what people were just doing without any triggers, support, markets or anything. Now, look, I want to first come back. Tricia's 100% right on focusing on networks, right? And I want to come back to this bloody plane. Everyone keeps talking about Merrin's plane, and I have a problem with Merrin's plane, right? You're talking about one plane, and I'm going to be a little bit blunt here. AEMO thinks it's the pilot, and it wants to be able to control the left engine, the right engine, every other engine, all the little engines, right? And there's a real problem of issue around control and services. An awful lot of work was done 5-6 years back now on the Open Energy Networks program, which AEMO and Energy Networks Australia were in together. And it got kiboshed because my opinion, and the opinion of many others, was it got kiboshed because it was going down the pathway of a very DSO type model, where networks would start to have an involvement of trying to go what was on and how they interacted with their customers. And if we think of some of the challenges that, like David was just talking about, and speed of light type exercise, if we really think about how the energy system works, about being in balance and flows, and despite everyone thinking that the networks, multi-flow is a new thing, multi-flow has been around for a long time, because that's how AC works. It changes direction every time the modulation crosses zero. So we need to think about how we balance parts of the network and services and dynamic operating envelopes. Huge opportunity to deliver significant improvement in productivity in networks, and to be able to signal to consumers how to make money, or sorry, how to save money more than anything. There is oodles of export available, or oodles of very cheap energy available, and there's lots of network capacity at the same time. Suck it down and being able to communicate those things. So that's the big change. So Merrin and thousands of little engines, she doesn't have to worry about it, because they're each individual feeder and section around it has its own voltage management, its own signals about dynamic operating envelopes, has its own community batteries acting as buffers, all driving energy costs down. That's not what the generators want to hear, and it's not what the retailers want to hear, but it's what the consumers want to hear.
Thanks very much. And there's a comment in the chat about bringing the consumers into that conversation, and that a fundamental shift is required. I'll throw this out to anyone who'd like, on our panel, who'd like to answer it. That is a really fundamental shift, bringing millions of people into the system where they're not just load points, but they're active participants. It changes the model for the generators, it changes the model for the retailer, and it changes from a proxy relationship through the retailers to an actual relationship. How, and that then brings these millions of little engines into the conversation. How on earth could that fundamental change take place? How on earth could we do that if we were to do that? And I'll take anyone who wants to put there.
I'll just make a simple comment first. It's not if, we are going to do it, it's going to happen. And I think it's not computationally or ICT challengingly a challenge to do it. It's about communication, a little bit of social education, and wresting control from incumbents. But I think I've spoken enough. I'd love to hear more from Patricia and David.
So Patricia had a hand up first, and then David will go to you second.
So I think we need to think about this as a spectrum. I have to confess, I have better things to do with my life than to spend it interacting with an app that even, in fact, the PowerShop app with members of my family are absolutely committed to. It's like a religious faith. From my perspective, I have better things to do with my life than getting a bip saying you can now turn the washing machine on. I might prefer a tariff which says, broadly speaking, power in your area is pretty cheap at midday. And on that basis, I'd be preferred on a weekday, but possibly not on a weekend, to move some of my consumption round. But I can't see myself hovering over a screen, my equipment. So this consumer engagement, this is a spectrum. This is some of us going, yep, I'm keen for this tariff. And this is, I mean, I saw a guy on the ABC a while, 6 months ago, who had 60K's worth of Tesla batteries and was claiming he was making money on them. He'd made $2,000 in the last year. Well, knock yourself out, Petal. It's not an investment. You're not making money. But if that's what you want to choose to do with your life, then do it. I see myself way down the other end. I suspect there's a big spectrum here of what engagement actually means.
Great. Thank you. David?
Well, such a complicated issue. But firstly, Patricia, absolutely. Like I have sons with EVs and rooftop, and they compete with each other on a daily basis about who's doing what, and I'd rather, read a book. But this is, I dare not use the aeroplane image anymore after Tim's comment without modifying it that we're changing the pilots. But this is a major part, and arguably the growing part of the system. Like the capacity on rooftops is possibly much greater, and business rooftops as well, than chewing up arable land for solar farms and wind farms. So this is, if we get, but the issue there is to understand the customer more. I get annoyed when I read researchers talking about my electric vehicle being available for frequency control. In current technology, I'm not into that. V2H, yes, but V2G, don't. So we make all these assumptions about consumer. We need to understand the consumer all the way from the point that they're currently confused, points made about prices promised to go down, they're going up. We're still digging coal out of the ground and talking about wind. I mean, they're just, I think they're must be quite confused about what we're trying to do here and the assumptions we make about how they'll behave. Then comes technology and regulation, all points already referred to, where VPP, smart grid, microgrids, these are ideas out there, but we haven't orchestrated them into any kind of plan, as Stephen says. And then regulation. At this All Energy conference, I believe it was the Solar Energy Society or whatever, the guy there, maybe the current regulation was designed in the 90s for a totally different situation. We've got AER protecting prices, AEMO with engineers, and AEMC with economists. How do you expect to coordinate all that? So we need new regulation, but do we need a new regulator, as has been suggested, to represent the CERs or DERs? Maybe. But I think consumer associations are not enough. They've got to get, the consumers have to be represented in the main regulatory game, and I don't think they are right now.
Thanks, David. Now, we're in our last 15 minutes of the session, and I want to make sure we reserve a little bit of time to focus really on what are the most important things that we will do moving forward, will do moving forward. There in the chat, there was quite a lot of talking about the fundamental nature of these problems, and in some cases that they are things we need to do in parallel. We need to do this and we need to do that. And there was a reference made to Medicare earlier, which was transformational for Australia. And could we really think about energy networks like a Medicare system? Is there a framework we can put in place? Again, I'm going to take anyone on the panel. Just please put your hand up and I'll call you out in order of people responding. Jordan, what are the parallel things we need to do?
Yeah, I wanted to go back. First of all, I wanted to touch with some of the questions that have been coming, or comments coming through the chat on what we've just been talking about, which is to recognise that consumers, for the most part, based on current understanding, as Patricia said, don't want to have to be asked to make a lot more complex, detailed, time-based decisions. We don't ask people when they're driving their car to figure out exactly which piece of road they should drive on and at exactly what speed. We just tell them, if you drive at a modest speed over a continuous period, you'll use less petrol than you do if you put your foot flat to the floor. So I think, as Patricia pointed out, the model for consumers, and as some of the comments have been made about elderly consumers and others, the model for consumers has to be something that is easy for them to embrace. That said, up until now, we've taken electricity to be a given. We've taken it as something we have to pay for, but everybody gets. It's a right. It's an entitlement. And if we start moving into a world where some people generate their own electricity and don't participate in the grid, and some people can't afford to do that or don't have the opportunity to do that, they live in a 30-story apartment building where they don't control the energy that's generated by the building. So we definitely have to go back, and that's why the reference to Medicare was made. We have to go back and think about what is the role of energy in our society. Is it a universal entitlement that as a community we must ensure everybody has access to? And if it is, then the community has to take responsibility through both government and company structures to provide whatever that baseline entitlement is, whatever that safety net is, if we use the Medicare type language. But if we decide that in fact energy is up, it's just for those who can afford it, then we have a very different place. And I don't think that's the society that anyone in Australia really wants. So I think that the big challenge is to make sure we understand that underpinning assumption that as a community, I think everybody has an entitlement to electricity. And in this new model, as everyone has said, that means we have to take that assumption and build it into the regulatory structure, the policy structure, the regulatory structure, and the implementation of the infrastructure, always recognizing that at the end of the day, it all has to be paid for. And so people will have to make payments along the way, but maybe we don't make payments the way we have in the past. The past, we've just been paying for electrons that we consume, and maybe that's no longer the right way to think about it. Maybe we have to be paying for the pipes through which we consume the electrons, or maybe we have to be paying for the exchange of electrons, or not paying if we're exchanging. And all of those things are possible with the technology that we have, computing technology and the electrical technology, but we have to decide what our objective is before we can implement the technology. And I think too many people jump straight to the technology. Now, there's a whole bunch of startups here and all over the world, all trying to say they can solve the problem, but they're coming at it from the bottom up, and they haven't addressed the overarching architecture of the system. So I think that's a place also, by the way, where well-experienced ICT community can really help, because systems engineering is a concept that takes that all together, and that hasn't really been applied in the past because we've inherited the evolution of the energy infrastructure. Today is the chance to sit back and say, what does the new one have to look like, and then build for that, rather than Band-Aid adapting what exists today.
Okay, we're in our last few minutes of the session. Tim's got his hand up. What I would like is from panelists who raise their hands, please get purposeful. You can make your comment, but please start to direct. This is what we could and should do. Tim.
Just quickly, I think to Patricia's point, we're really talking about sorry, but my screen up something funny. We're talking about devices and things being active. We're not talking about individuals having to turn things on or off. But to Jordan's point, what we really have to do is get somewhere in the future and think about a future that we want and what it means coming back and how we deliver it. And the idea that some people could abrogate responsibility for the community commons that is the network troubles me immensely, because they will still need some of it, but the current model where we have volumetric pricing doesn't reflect what the service, the good, and the value of the networks are. And I think we've really got to approach that, and we've got to communicate that to consumers and then say, how do we actually remove the friction from net, which is what volumetric tariffs are, remove that friction so that I can make the most of my rooftop solar, that I can send it to a community battery and get it back, my energy back for free, paying a service fee for the storage. How we do that, I think they're the things that the discussions we've got to have around community savings, our place in the universe, of what we're trying to do to deliver the transformation.
Great, thanks, Tim. Now I'm going to work my way up approximately through our speaker list. So, Patricia, I'm going to ask you next. Last few minutes, what could and should we do?
I think we need to be more grounded in the current system. So, unlike those people who are going future back, I'm actually current forward. So, and we have widely different views about what's there already and what isn't. So I think we need to be more grounded in that. We need to be clearer about trade-offs, and I think we probably need to focus rather than expanding the locus of things that we're planning to renovate right now.
Thanks, Patricia. We have 6 minutes left. David, what could and should we be doing?
I just want to make a plug for research and teaching, which are integrated immensely. That research, first of all, this is hard. This is a complex thing, so it needs research, and our situation is not the same as anywhere in the world. Okay, we can draw similarities with ERCOT and maybe others, but our long stringy grid, our island nature, blah blah, we've always solved our own problems in this area, and we need to keep doing that, and that means research. Research also feeds into education and motivating people. We need to motivate people to study the energy transition, to see that as a career future. That will make I think that would be a good contribution to helping here.
David, Jennifer, what could and should we be doing?
Oh, wow. I think, first of all, basic businesses are about building a business, is about building a value proposition. So the issues around the consumers becoming part of this, we have to take the time to listen to them, hear what they think is value, and create a value proposition for them so that they will engage with it at the level that they want to engage for. Maybe they want to just do the switch that Wayne has talked about, or maybe they want to have a more involved perspective. But we cannot assume that we're going to be paternalistic about this. We're just going to build a grid and people are going to come along and want to join it. This is the new age of individualism. We need to be respectful of that. We need to understand what people want to achieve, and we need to make sure that our regulations and all of the research and etc. has a time limit from it. We can't be saying, okay, well, we can pursue research, but we've got a grant that's going to take 10 years to do it, or we've got a research program that's going to tell us at the end of a year that we need to do more research. We have to be more goal time orientated. We have to understand that there is a time constraint here, and look at all of our systems and map them across a timeline and say, where can we save some time?
Thanks, Jennifer. We've got 3 minutes left. Stephen.
Yeah, very quickly, I'd agree with Patricia's comments on consolidation and focus. We really don't need lots more initiatives in parallel. We need to join in a focused effort, and I think a big part of that is for digital professionals, ICT, to actually support the energy folks in areas where ICT is really good, like systems architecture, systems engineering, digital intelligence, and so on. Because at the moment, there are energy folks doing that, but in some cases, it's not really at the cutting edge. So we need to come together and work together to solve this.
Thanks, Stephen. Jordan?
Yeah, look, I just think all these things, we have to continue these conversations, and I agree with Patricia. We have to very quickly focus in on where we can make a difference. And Australia 4.0 has tried to focus away from the biggest picture down to the distribution and consumer network. Now we need to try and find some key elements there that are going to be the levers and the drivers that enable us to build something that works and to create opportunities for our solutions to be solutions all over the world.
Jordan. Tim, our colleagues have given us a whole minute if you wanted to add any final thoughts to what we could and should be doing.
I think we've got a real challenge. I think we forget how savvy consumers can be and going to the supermarkets otherwise and buying their other goods, and we don't really have some of that opportunity to be active in the energy marketplace. So even, talking about value propositions for consumers so businesses can sell them something, the question is whether consumers are a player and they have access to the wholesale market or the pricing of flexibility or otherwise, which has been developed in the UK, gives us new opportunities and new paradigms. And I just think we've got to be open to those. But the trouble at the moment is our principal incumbents, the retail interface, does not want to see consumers either using less energy or using more energy at less amounts. Just look at AGL, where they're offered to provide cheap EV charging at night. That's just to bump up their coal-powered power stations and to hold the price up at night by demand. It's not helping us, and we've got to move faster. I'm sympathetic to the sort of points that Stephen and Patricia were making about how much we're doing, what we need to do, how much research, how do we get on with these things. But we need to be doing a lot of the things around demand management a lot more quickly.
Thanks, Tim. And that brings us right up to time. And so I want to say thank you very much to our panelists. Wayne, I'll hand over to you in a moment. Thank you very much to our panelists. This is complicated. This involves lots of people, and it involves lots of people adopting a different way of thinking about energy and different ways of thinking about the way that we approach this. In the chatter, there's been a lot of conversation about some of those differences, some of those dynamic tensions in the system, and thinking differently about the transition towards net zero and why we're doing it, and the role of energy, the role of electricity plays in our society is really part of that thinking differently. Wayne, I'm going to hand back to you. Panelists, thank you very much for your contributions and for your active engagement in Australia 4.0 to date. Wayne, over to you.
Thanks, Ian. Thanks, everybody. To your challenge, before I sum up, there's two key issues here. I guess it's my age to some degree why I'm saying this. First of all, the industry, whoever constitutes the industry, but in our case, in the ICT world, we have a number of visible bodies. And for instance, I'm a fellow of the Australian Computer Society. I think they have a role to play, as does Pearcey, as does potentially AIIA and the engineering landed societies like Engineers Australia and the WESA, etc. So can we come together and collaborate? Because this is a broad societal problem, and I'm hoping we can. Inevitably, if we want to change anything, we have to engage with government. There's no alternative. That's the way democracy works. How and when we engage is a difficult issue, but I think we must not let vested interests take over. We have to do what's best for our nation, and I think this will be how we affect change, and what changes we want will become political, because people will not put up with increasing electricity and energy prices. It's just, that is not the nature of our nation. So with that, I'd just like to thank everybody on the panel today and all our previous panelists. And I would reflect that Ian's presence today isn't by accident. Ian was the one that encouraged me personally to take on this big, hairy challenge, because this is a huge issue for our nation, and we've just tapped into a little bit of it. What we do next is probably even more challenging than just trying to define what it is we're trying to resolve here. So in our second session, which will start in an hour, we're going to start to address some of those issues and make a plan for 2024, because we don't want to lose this momentum. Your personal interest, all of you who are logged in here today, we want to hear from you. Please write to us. Make all your suggestions. We're trying to capture this moment and say, let's not waste the collective energy of those who are interested in this topic today, and move forward. So with that, I thank you all very much for your participation and look forward to seeing you in 1 hour's time. Thank you.